Greetings, math nerds. This is a lesson on parallel lines. Parallel lines, by definition, are two lines that will never meet because they are always the same distance apart. Your diagram, I've just traced two parallel lines. You'll often see a third line that crosses the parallel lines in diagrams, and that is called the transversal. Now, when these lines cross your parallel lines, you're going to end up making different kinds of patterns. Basically, there are three rules for parallel lines, and they come down to the shape of the pattern that you'll see. So here's a parallel line indicated with a little arrow. Now to shape, I'm going to do the first one. Alternate angles are known to be equal. Let's trace that and talk about it. So if I can find a parallel line and another parallel line that are crossed by a transversal, then the angles that are made on the alternate sides of the transversal, so here on the left and there on the right, we have indicated with a dot two acute angles. And by law, those angles are always equal. And that pattern is quite often referred to as the Z pattern. And the Z pattern indicates two equal angles. If I was to retrace different angles here, there's more than one way to do these questions. So watch this pattern. Parallel line, transversal. So now we have an angle made on the left. You'll note that's acute. I'll put a little X in there. And the angle to the right of the transversal is also obtuse, and those angles are also equal. Same rule, they are called alternate angles, and we typically refer to that as the Z pattern. In terms of reason, Z pattern is never offered as a reason why angles are equal. Z pattern is a strategy to help you to find the angles. It's not a reason. The reason is they are alternate angles. They are actually called alternate interior angles because they're on the inside the parallel lines. Think of those being as on inside the train tracks. Now the next pattern is called corresponding angles. I'm going to trace on this diagram four different ways to show you corresponding angles. Here we go. Parallel line, transversal. You can see that makes the letter F. Translated, that means the angle below the parallel line, which is obtuse, and the angle below, which is obtuse, are equal. And that's called the F pattern. Now, not all the F's need to be perfectly, they can be upside down, they can be backwards. They can be upside down and backwards. I'm going to trace all the ones that I see in this diagram to help to introduce your brain to thinking all these different ways. So parallel line, transversal, the angle that's above the parallel line here, which is acute, is equal to the angle above the parallel line there, which is also acute. And that's what I would call like an upside down F. Let's do now a different F pattern. We're looking for parallel lines and transversals across to make a pattern similar to an F. So how about this one? Parallel, transversal. That's what I call a backwards F. So the angle that is below and below on the same side, in this case the left-hand side of the transversal, they're equal. The angles are obviously both acute, and that helps because they look the same. One more pattern. So we'll take this one off. We're looking now at our parallel lines one last time. Let's do parallel line, transversal. Now we have the option to show the angle above the parallel line, which is obtuse, and this one, which is obtuse, and they're both on the left-hand side of the transversal. They're always going to be equal. So you need to know that's not called the F pattern. They're called corresponding angles, and the strategy we use to find those is the F pattern. But the reason is actually that they're corresponding angles. The last pattern is the C pattern, and it's different. Parallel, parallel, transversal. They're called interior supplementary for a reason. Interior means on the inside, so that angle there, which is obtuse, and this angle here, which is acute, they're not equal. Interior supplementary angles are not equal. They add to give you 180. That's what supplementary means. They add to give you 180. This is called the C pattern. And interior supplementary angles add to give you 180 degrees. So we can look at the backwards C as well. Parallel, parallel, transversal. On the inside of that parallel lines we have an acute angle here and an obtuse angle there, and they would have to add to give you 180 degrees. And those are the three rules for parallel lines. Either a Z pattern making alternate angles equal, an F pattern making corresponding angles equal, or the C pattern where the inside angles add to give you 180 degrees. Let's now apply those rules to the problems at the bottom. I'm going to teach you some special strategies that will help you get through some more difficult questions. Okay, part A. The first thing that I notice is I have two parallel lines. Therefore, and I also have a transversal that crosses them, I can use the three different rules to help me to find a whole bunch of angles in this diagram. However, just because you have parallel lines doesn't mean that other rules you learned earlier don't still apply. So what I see, for example, is I see the straight line that's cut into two angles. 120 here, which means x would have to be 60. And that's because they are supplementary to each other. That's one way to do x. Now somebody else might see a different approach. Somebody else straight from the beginning might have seen an F pattern to get it. Angle Z. For example, maybe if you're looking at patterns and you see this, maybe you see the given angle of 120 is above the parallel line, so therefore angle Z and 120 have to be equal. That's possible. One of my biggest pieces of advice I can give you in this section is don't restrict yourself to only finding angles that you're asked to find. Please write down as many angles as you know and you see, even if you're not asked. So for example, I look at this and I see the scissors, the vertically opposite angles, and I see this is 120 as well. And then maybe from that little extra angle you weren't asked to find, maybe that would confirm in your mind that these angles, Z and 120, should be equal because they're also alternate angles. Maybe you see this Z pattern. X and Y are equal, and therefore X or Y would equal 60 degrees as well. So please find as many angles as you can find to get to where you want to go if you're stuck. Do not limit yourself to finding only angles that you're asked for. That's a Christie rule number 1. Find as many angles as you can to get to where you want to go. Now diagram B is a special diagram because it has two sets of parallel lines. Those are marked by a single arrow, and these are marked by double arrows. In math, that's called a parallelogram. And parallelograms have special features that you should be aware of. For example, this side and that side are not only parallel, but they're also equal in length. This side and this side, same thing. Parallel, also equal in length. So maybe you're starting to see these patterns, and maybe you can see that X is also equal to 50 degrees because it's alternate to the given angle of 50 degrees. Maybe you can see this straight line, and therefore the angle adjacent to X on the other side would have to be 130 because those two angles together have to add to give you 180. To keep going, maybe your brain will register that what we have here is a C pattern. So if we have 130 on the inside here, this would have to equal to also 50. Maybe, however, you saw the F pattern. If this angle here with X was 50, then angle Y is also equal to 50. Maybe your brain registers the Z pattern. So if Y is 50, Z is also going to be equal to 50. You should see a pattern here. The angle that's adjacent to Z on the inside of the parallelogram would be supplementary to 50 or 130. In a parallelogram, a four-sided figure, you will always end up with the interior angles in the opposite corners as being equal. So if you retrace what we had written down, the Y is 50 because these are equal, and these two that were not asked for, they were both 130. And the inside of a four-sided figure, whether it be a rhombus, where all sides are equal, or a trapezoid, or a square, they're all going to have one thing in common. The sum of the interior angles of a four-sided figure will always be 360 degrees. Triangles are 180, four sides are 360. Part C. Another good rule that will help you survive geometry. Before you start the question, investigate shapes. I see a triangle there. I see a triangle there. And I see a parallelogram there. So all three of those things might help you get through this question, because you should know that triangles, the sum of the interior angles of a triangle add to give you 180. And now you know that in a parallelogram, the opposite angles are also going to be equal. So perhaps you see this triangle. And you know that the corner, the third corner, has to equal to the sum of 28 plus 105 from 180, which makes it 47 degrees. Perhaps you could then say, well, that 47, then angle Y must also equal 47. This is a parallelogram. Maybe you see something different. Maybe you see that Z pattern, and that Z pattern would help you to get to the answer that X would have to also equal 28 degrees because of this. Maybe you found this angle in here first. Maybe you found this angle to be 105 and subtracted it from 180. You could also do a C pattern, like here. So 47 plus 28 plus a missing angle 105 would have to all add to give you 180 degrees. The next piece of advice, which I think is awesome for geometry, is this. Don't be afraid to extend your lines. Say I do this. Then maybe the parallel lines become more obvious. Don't be afraid also to highlight when marks show that the lengths are the same, because that will indicate we have an isosceles triangle situation. There are so many ways to start this question. It depends on what you see. Perhaps somebody out there might see the Z pattern and get that angle C is 80. Somebody else out there might start with this isosceles triangle and do 180 minus 80, which is 100, divided by 2 to get 50 degrees for A and 50 degrees for B. Somebody else's brain might see scissor patterns, what we call vertically opposite angles. They might see that B and C together have to add to give you F. So 80 and 50 would be 130. So F would be 130. Another person might see that if A is 50 down here, then D would have to also be 50 because of the Z pattern. I wouldn't be surprised if somebody else saw that D and E are vertically opposite, and that's 50 degrees. You do a quick check. Oh, look at this. F and E, 130 and 50 adds to give you 180. Oh, look at this. E, C, and B, 50 plus 80 plus 50 adds to give you 180. All kinds of ways to get around that diagram, and very, very unlikely that you and your neighbor will see it done in the same way. So don't be afraid to try your own approach. Let's have a look at question E. I see two parallel lines, and I see an X in the corner between two lines. So one of the things that I said to you a few minutes ago was one of the best strategies for being successful in geometry is sometimes extending your lines. So if you extend this line and this line, i.e. your parallel lines, what you've just created here is a very nice triangle. So you want to find angle X inside the triangle. You will have to find the other two angles inside the triangle to solve. There are many ways you can do this. Perhaps you would see this angle down here below the parallel line would be 123 as well, because it's a corresponding angle, the backwards F pattern. And then the angle beside that, what we call the adjacent angle, inside the triangle up here, would be the supplement to 123, so it would be 57 degrees. Now we know that side, and we need to find the other angle inside the triangle here. And the angle 109 and the angle inside are adjacent, supplementary. That would make that angle 71 degrees. So 71 and 57, add those together to get 128. Subtract that from 180, and then that would give you angle X to be 52 degrees. Notice I try to always write my degree symbol. The degree symbol is as important as a centimeter or a millimeter for a unit. Whenever you're doing a question, you should always have a unit. Now, for diagram F, this is one of those examples where one of the first things you should do is investigate all the different shapes I'm going to trace them, then I'm going to erase them. So I want you to see what I'm going to draw. First of all, what often gets overlooked is the outside big triangle. Then there is the inside triangle here. There's a triangle here, a triangle here. There's also this whole triangle. All kinds of triangles. And then, last but not least, there's also what we call a trapezoid. And the trapezoid is another four-sided figure with only one set of parallel lines. So here. So in the trapezoid, we have C patterns on either end. And that might be helpful for solving missing angles. Okay, here we go. There's no right way to solve this question. There's just your way. I'll talk it through as many ways as I can see. Hopefully one of them will speak to you. So what I'd probably do first is I would go with the obvious ones to me. I would find angle 4, because angle 70 plus 75 would be 145. So I'd probably find angle 4 to be 35 degrees. I would also immediately see angle 3 as supplementary to 75. They're on a straight line. So angle 3 is an obtuse angle, 105 degrees. Now where you go from here is your choice. I'd hope that you would see angle 4 and 30 and 6 together add to give you 180. So if 4 is 35 and the angle 30 is marked, that's 165. So angle 6 should be 115. Here's a kind of a unique one. Different perspective. F pattern. So 1 and 2 and 75 have to be equal. Perhaps you see this triangle, 105 and 30, 135. So angle 2 would have to be 45. So therefore angle 1 would have to be 30, because 2 and 1 together have to equal 75. But maybe you didn't see that. Maybe instead you would see the Z pattern. That one's pretty clear, this Z pattern. So angle 1 would certainly be equal to 30 degrees. We have 30 here, 45 there, 105 there. Angle 5 and angle 4 are equal because they're corresponding angles. Or you could do 115 and 30 is 145. Subtract from 180 of the triangle to get your 35 degrees down there. All kinds of ways to solve this question. The fact of the matter is you have to find a place to start and just simply work your way around the diagram until you get to the angle that you want to find. Okay, in diagram G, we have parallel lines, of course. We have also these two stars. And anytime in a diagram you see two measurements, or two equal letters, or two equal symbols, that should scream at you that those angles are also equal. So, a bunch of ways you can do this. I see vertically opposite angles. I see angle 3 is going to equal 40 degrees. I see angle 3 and angle 7 are a C pattern. Therefore, angle 7 would have to equal 140 degrees. I have to add to give you 180. They're on the inside of two parallel lines. I see angle 5 has to be supplementary to 70, so 110. I see angle 6 and angle 7 are on a straight line, so angle 6 is 40. I see a triangle here, so 70 and a 40 is 110. So angle 2 has to also be 70, which then by default makes this triangle isosceles because it has two equal base angles. Angle 1 and angle 2 are equal, therefore it must be 70. And angle 1 and angle 2 are vertically opposite from angle 4, so they must be equal of 140. All kinds of ways to solve those questions. Very similarly for H. Maybe you see what I see. Straight line, angle 4 and 130 are adjacent. So 4 has to be 50 degrees. Maybe you see the C pattern here. 1 and 130 have to add to give you 180. So that's 50 degrees. Maybe instead you saw this Z pattern and saw that angle 1 and angle 4 are the same, both 50. I'd like you to see this perspective. If you hadn't before, here's a C pattern. So if angle 1 is 100, angle 2 would have to be 80. So angle 2 plus 3 plus 1 to add to give you 180. So angle 3 is also going to be 50. Supplementary. And last but not least, diagram I. Diagram I is quite often a very challenging question for some people. And it has to do with visual, like a spatial identification in your brain. If you see that as an F, now that I've traced it, you should recognize that angle 35 and angle X have to be equal. Therefore, X is equal to 35 degrees. If you see this pattern, transversal, parallel, parallel, then I would suspect you'd guess very well that the other angle here would be 65 degrees, which is too big for me to write in there, but ideally it should be written where it belongs, in there. So I'll erase that off and write it in smaller. Well, shit. So 35 degrees and 65 degrees. Again, remember the pearl of wisdom. Find more than you're asked for to get to where you want to go. Now you could find Z or you could find Y. 35 plus 65 is going to be 100. So Y is going to be 80. Then maybe you see that Y and Z are alternate angles. Z pattern. This question is really hard for a lot of people. And I'll tell you the last piece of advice that will get you through this chapter. And that is, whenever you get to a diagram that gives you a bit of a challenge, one of the first things you should do is literally pick up your page and rotate it around to enable your brain to see different shapes. So rotate it, turn it halfway, 90 degrees to the right, turn to the left, upside down, rotate around until you see some sort of a pattern, either be an F or C or a Z or straight lines or triangles or parallelograms or trapezoids or whatever you need to do to be successful. If there's more practice in your booklet after this page, please do it first and then do your assignment. If you have questions, come find me.